This lesson 8.2 is about Introduction to Electricity and the Ohm's Law. Our lesson 8.2 has the following goals: to explain the nature of electricity and its uses in our daily life, and to solve problems involving Ohm's Law. Introduction to Electricity. Electricity is a fundamental part of each and every day for most people in the world. It's how we power our phones, computers, homes, and businesses. Without electricity, the world would look much different. That's why it's important for everyone to have a fundamental understanding of electricity. In this lesson, we will discuss the basics of electricity, including the basic electrical knowledge and terms. The uses of electricity in our daily life. Electricity is the flow of electrical power or charge. Electricity is a basic part of nature and it is one of our most widely used forms of energy. Many cities and towns were built alongside waterfalls, a primary source of mechanical energy that turned water wheels to perform work. As shown in the picture at the right are the different uses of electricity in our daily life: on motion or power, on heating or cooling, on light, and in communication. Before electricity generation began over 100 years ago, houses were lit with kerosene lamps, food was cooled in ice boxes, and rooms were warmed by wood-burning or coal-burning stoves. Beginning with Benjamin Franklin's experiment with a kite one stormy night in Philadelphia, the principles of electricity gradually became understood. Thomas Edison helped change everyone's life. He perfected his invention, the electric light bulb. Prior to 1879, direct current electricity had been used in arc lights for outdoor lighting. In the late 1800s, Nikola Tesla pioneered the generation, transmission, and use of alternating current electricity, which can be transmitted over much greater distances than direct current. Tesla's inventions used electricity to bring indoor lighting to our homes and to power industrial machines. Basic electrical terms. Electricity is the movement of electrons from one place to another. As we learned before, electrons are subatomic particles with a negative charge that can flow through any material. Also, as in lesson 8.1, charge is the physical property of subatomic particles. Negative charge is carried by electrons, positive charge is carried by protons. Current I is the flow of electrons flowing through wires and components. The unit of measure is amps. Resistance R is the opposition to the flow of electrons. The unit of measure of resistance is ohms. Voltage V is the force behind electrical flow. Its unit of measure is the volt. Conductors are types of matter that electrons flow through easily with low resistance. Semiconductors are types of matter that electrons can flow through under certain circumstances. And insulators are type of matter that electrons flow through with great difficulty and high resistance. Basic circuits and parts of a circuit. A circuit is a path through which electricity can flow. Most circuits have at least three parts. An energy source. A circuit needs an energy source to pass a charge through the circuit. An example of an energy source is a battery. One or more loads run by electricity. A load is a device in a circuit that operates using electrical energy. Conductors or wires that connect the two. A conductor is a material that allows electrical energy to flow through it easily. A switch is a device that is used to control the flow of current through a circuit. A switch works by separating or open or bringing together closed two conductors attached to a circuit. The figure below shows a closed circuit. In other words, the switch is closed, so the current flows through the circuit. And the figure below shows an open circuit. The switch is open, so no current flows through the circuit. The Ohm's law. George Simon Ohm, from 1789 to 1854, was a German physicist and school teacher who discovered the mathematical relationship between current, voltage, and resistance. According to him, V is equal to the product of I and R, where V is the voltage in volts, I is the current in amperes, and R is the resistance in ohms. Let us do some examples now. Example number 1. If a circuit has 2 amperes of current running through it and the total resistance in the circuit is 19 ohms, then what is the total voltage? Solution. Using the formula V equals the product of I and R and substituting the given values, you have V equals 2 times 10 or V equals 20 volts. Example number 2. If a circuit has total voltage of 9 volts and resistance of 3 ohms, what is the current in the circuit? Solution. Using the formula V equals I times R and rearranging to solve for I equals V over R. Substituting the values, I equals 9 over 3 equals 3 amps. Example number 3. A circuit is supplied with 15 volts of voltage and has current of 3 amperes. What is the total resistance in the circuit? Again, using the formula V equals I times R and rearranging to solve for R equals V over I. Substituting the values, R equals 15 over 3, which is equal to 5 ohms. Example number 4. A house is supplied with voltage of 120 volts. If the total resistance is 60 ohms, how much current is running through the wires? Solution. Using the formula V equals I times R and rearranging to solve for I equals V over R and substituting the values, 120 over 60 equals 2 amperes. Example number 5. In the following circuits, find the unknowns. In the first circuit, we are given the resistance of 100 ohms, the voltage is 120 volts, and we are required to find the ammeter reading in milliamperes. In second circuit, we do not know the value of the resistance. We are given the voltage of 24 volts and the ammeter reading is 600 milliamperes. Solution. For the circuit at the left, the unknown is I in milliamperes. I equals V over R. which is 120 over 100 is 1.2 amperes. Converting to milliamperes, we multiply our answer by 1,000. Thus, I equals 1,200 milliamperes. For the circuit at the right, the unknown is R, where I is 600 milliamperes, or this is 0.6 amperes by dividing 600 by 1,000. So R equals V over I. Substituting the values, we have 24 divided by 0.6 is 40 ohms. Thanks for watching.